All right, hello everybody. Welcome to day 2 of functions, where we're learning about modeling and predicting change so we can solve real world problems that change creates and learn how to manage change. So remember, as we're going through this, the only thing constant in life is change. So yesterday we learned what a function was. And one of the key things that we learned about a function is that a function can be thought of as a machine that assigns one input to one output, and that function machine changes the input into an output. So functions are used for change. So what we're looking at today are what we call a composite function. And what a composite function is, as you can see here, it is a function that is made up of two or more functions. And it is formed by combining multiple functions in a process that sends the output of the first function as the input to the second. Okay? And in math, a composite function is formed by placing one function inside of another function using a series of parentheses called nested parentheses. So I'm going to go through and show you what all that means in the next slides and in a few examples. So if we look here at a real-world example of what a composite function is. So remember, it is one function that takes an input and then sends that input into another function. All right, a coal-fired plant is a real-world example of a composite function. So it takes raw coal. So raw coal is what we're going to call the input to function number one. And then it takes that raw coal and it sends the prepared coal to a boiler to combust it to generate useful thermal energy in the form of steam. And we call this second process function number 2. So here you go. Here's our first function machine, function number 1, called fuel preparation. And we see that raw coal is the raw materials that are the input to that function machine. And then that function machine changes that raw coal into pulverized coal, and that output of the first function becomes an input to the second function, where the fuel combustion is. So that pulverized coal is put under heat, and that heat creates an output of steam. And what's not included in this function diagram here is that steam goes into the turbines and turns the turbines, which provides power and electricity to millions of people in the United States of America. So the process of turning raw coal into steam, into electricity that all of us enjoy, is an example of a composite function. So a composite function is when a function is followed by another. So we have here a function machine, which we're going to call G. And we have function machine, which is called F. And we have an input to G. And that input to G goes through and comes as an output of function F. That's what a composite function is. So if G of x equals 2x and f of x equals x plus 3, then G or f of the G of x equals 7 when x is 2. So let's look at how that works. We have our function machine, which is named G, and its rule is 2x. We have 2 when the which is the input, since our problem says when x equals 2. And then that 2 gets changed by the function rule 2x to 4, which is the output. That output goes into function machine F, which is x plus 3. So 4 plus x plus 3, that changes it to a final output of 7. So that is how a composite function works. So what we're going to do now is I'm going to quickly pause, and change from laptop mode to tablet mode. And we will do a few examples together of composite functions. And then I will give you your assignment for today. All right, so here you are. I am back in tablet mode. So let's go over here to our Canvas board. And I'm going to write two functions here. I'm going to write, let's write g of x equals x squared plus 6x plus 9. And the h of x is going to equal the square root of x minus 10. So what I'm going to try to find is the g of the h of 9. All right, so what this means is the first thing that I'm going to do is find the h of 9, and then I'm going to take the answer for the h of 9 and insert that into g of x. Okay, so what you have here is you have your inside function and you have your outside function. So let's start with the inside function, which is h of 9. So the h of 9 is going to equal the square root of 9 minus 10. So the h of 9 equals 3 minus 10. So the h of 9 equals a negative 7. So I'm looking for g of the h of 9. So I take my other function, g of x, and I'm going to put that negative 7 in for x. So every place I see the x, I'm going to place a negative 7. So negative 7 squared is 49. So 6 times a negative 7 is a negative 42, and then plus 9. So 49 minus 42 is going to be 7. So 7 plus 9 equals 16. So the g of the h of 9 equals 16. All right, let's do another. All right, so this time we're going to use the same two functions. So g of x is still going to be x squared plus 6x plus 9. And h of x is still going to be the square root of x minus 10. All right, so this time let's find the h of the g of negative 1. All right, so again, I have my inside function and my outside function. So I start with the inside function, which is g of negative 1. So the g of negative 1 is going to equal negative 1 squared plus 6 times a negative 1 plus 9. So negative 1 squared is 1. 6 times a negative 1 is a negative 6 plus 9. All right, so the g of negative 1 equals 4. So now we're going to take that and plug it into the h of x, which is equal to the square root of x minus 10. So the h of 4 is going to equal the square root of 4 minus 10. So the h of 4 equals 2 minus 10 because the square root of 4 is 2. So the h of 4 is going to equal negative 8. So the h of the g of negative 1 equals negative 8. All right, and we will do one more since the third time's a charm. This time we're going to change. We'll have f of x equals 3x plus 2. And we will have let's go with, again, the same g of x, which is going to be x squared plus 6x plus 9. And this time we are looking for the f of the g of negative 2. All right. So like we saw in the video, and I'm sorry I didn't mention it earlier, these are your nested parentheses, parentheses within parentheses. All right, so we start with our inside function, which is the g of negative 2. So the g of negative 2. So negative 2 squared is going to be 4. 6 times a negative 2 gives me a minus 12 plus 9. So the g of negative 2 equals 4 minus 12, which is 8, or a negative 8, plus 9. So the g of negative 2 equals 1. So now I'm going to take this, and I'm going to go back to the f of x, because I'm looking for the f of g of negative 2. So we're going to take the f of 1. All right, so the f of 1 equals 5. So the f of the g of negative 2 equals 5. All right, so I hope you enjoyed doing that as much as I did. All right, so what we're going to do now is, if you look over to Canvas, all right, so your assignment today is going to be composition of functions. It's going to be doing the same thing that we just got done doing. And what you're going to do is you're going to solve the problems to find out pieces of information. And all these are going to be clues that help you find a mystery country at the end. Okay? So listen very carefully to two things. Number one, you need to work out all of the problems. All right? Where it says up here, choose 4 out of 5, that means you choose 4 of your answers and apply those 4 answers to the decoder down here. So the answers that you have, like for example, if one of the correct answers is number 29, it gives you a hint to the country that you're looking for, which the word French is there, so that would potentially be the official language. Okay? Also, I want you to look at this second part here, and you see how it says F, and there's a little circle between the G and the 5. All right, that means to find the F of the G of 5. So you're going to do what we just did, is you're going to first find the G of 5, and then put that answer into the F of X function. Okay, same thing for the one below it, where it says to find the G of F of 3. That little circle between the G and the F means G of F of 3. Okay, so if you have any questions, I cannot be on Google Meet today because it's Wednesday and that's our meeting day, but you can email me and I will help you and get back to you as soon as possible. So have a great day, everybody. Enjoy the composition of functions.